really cold.
Alright, so what we'll do is we have been discussing steady state error. Okay. Look at the definition I gave you. Can one of you read the definition?
What's that? Pull up.
It says it's the error between output and input as the time goes to infinity, right? So we did define error. Now keep in mind, we are going to discuss, we have to discuss closed loop systems here, okay? And in the context of control, this is much more common as well. So steady state error will denote this by E hyphen infinity. Okay? This is equal to limit as t goes to infinity E of t. Okay? This is essentially your definition. This can also be written as limit as when time goes to infinity, what happens to frequency?
It's the opposite.
Opposite, yes. It is S goes to 0. This is how it's defined, okay? Steady state error.
That big E represents error.
Error, yes. Steady state error in terms of frequency. Right. We looked at what that definition was last time.
We showed two systems, and then components in those systems.
So what about our tests, midterm tests?
Yes, your midterm tests are being graded.
We have about Tuesday?
I'll have them this week.
Can we go to your office tomorrow? Is that what you're saying?
You'll get them today. You can come to my office today, okay?
I'll probably just wait Tuesday. Oh, tomorrow, I see.
Yeah.
Okay. I'm just going to give you this definition, alright? And now keep this in mind. This is a very critical, this is one of the definitions, a very basic definition you can use, alright? Now, we'll look at some other derived definitions of this, alright? What do you know ES as?
Yes.
I gave you this. It is R of S minus C of S.
Oh.
Okay. And C of S is what?
R of S times E of S?
No, E of S times G of S.
Oh.
You remember, keep in mind this figure, and we are talking in this context. I'm going to draw this. This is the error signal. This is G of S. This is R of S. Okay, positive. This is C of S. And you have H of S.
E of S is supposed to be between G of S and R of S.
So it's the difference between the signal. What we are going to do is, so this is the generic definition, right? This is a feedback system, closed loop system, right? There's a feedback going in. We introduce another system which we'll discuss, all your discussions will be in the context of this system. You have G of S. This is called a unity feedback system, and it should make sense intuitively. Why is this a unity feedback system? Anybody?
Because there's no second, like there's a G of S, but there's not an H of S.
H of S is there. What is H of S?
Signal, essential.
No, what is the value of H of S here? This is 1. Okay. You understand? So if I remove this, this will become C of S, right? That's what I told you last time. Remember? So here, what is the signal here? It is C of S, H of S, right? That is going in.
Mm-hmm.
If I remove this, it will be
C of S.
C of S. And what is the signal here?
C of S.
C of S.
R of S.
It is C of S. Right?
Yes.
What is H of S?
1.
1. Okay, this is a unity feedback system. You got it?
Yes, sir.
Yeah, just put it back. Alright, so look at this. So I can write, combining these two, and this is for unity feedback system. This is for unity feedback system. And C of S is simply E of S into G of S. Correct? No, that's actually not true. It is true anyways. This is, okay, this is not quite true. Okay. So this is specifically for unity feedback system. See if it makes sense.
Yes, what's it?
What is E of S here?
It should
Where?
be
Here E of S is,
R of S times G of S.
no, it's R of S minus,
C of S times G of S.
yeah, right?
You have H of S.
C of S, H of S, right?
I thought it was G. Oh wait, never mind. Sorry, I just read it.
Okay. Here E of S is,
R of S minus
R of
C
S minus C of S.
right. You got it? So this conforms to unity feedback system. This is simply true for either this or that. Alright? So if you look at this, if you combine, I can write E of S is equal to R of S minus E of S G of S, right? And I can, this will become
Are you trying to solve for
E of S. I'm solving for E of S. So E of S would be R of S divided by 1. Okay. And if I substitute this back here, you're going to get E infinity, which is steady state error, limit S R of S.
if R of S is 1 over S, isn't that technically
Right, we'll talk about that, okay? This is another definition. What this does is, it defines steady state error purely in terms of the transfer function G of S and the input. Alright? So if you look at here, I'm going to give you this, see if this makes sense, is what? Limit S tends to infinity R of S, sorry, one over 1 plus G of S. Does this make sense? If R of S is a step input, right, it will be 1 over S, and that 1 over S and S will cancel. You get this.
get a picture of it?
Hmm?
Can we get a picture of it?
Okay. E ramp. What is R of S for E ramp? Ramp. If it's a ramp function, R of S is 1 over S for step. Okay. R of S is 1 over S square for ramp. Similarly, R of S is 1 over S cube for parabolic. Okay. And you can find this out in the textbook. Any idea what is R of S for impulse? Which I asked you in the exam.
It's
I don't think any of you got this right.
can I Google it? Oh, my phone's dead. Never mind. 1 times
That's it.
1.
Thanks. Okay, so E ramp is what? Limit S tends to 0, 1 over S G of S. Okay, and the last one. I'm going to write it here for your convenience. E parabolic is limit S tends to 0, 1 over S square G of S. Okay. These three are, so 1, 2, 3, 4, and 5 are very important formulas. Your next test will be around this chapter.
You want to do it?
Tori's not in the way. You're in the way.
I see you. I'm glad.
Try to copy it down so
Okay.
Agree, man.
So next test will not be an open book. Next test will be closed, but you can get your notes. So make sure you have your notes.
Dr. Sun,
Hmm.
so you've got on equation, I think that's 2, you have E infinity limit SRS, is that correct?
Right. So this is the basic definition. Okay. So try to understand. This is the steady state error definition, right?
Yes.
Steady state error is error. This is error
Mm-hmm.
when time goes to infinity.
Mm-hmm.
That becomes
Error as frequency approaches
0, but there is a s added here. Okay, this is by definition.
Okay.
Okay. Now what I've done is when you're given something like this, what are you really given here? You're given this g, for example, if you're given this, you're given g of s, right, in the problem.
Mm-hmm.
And you're given r of s. You understand? So we want to derive it in terms of g of s and r of s. Alright, you don't want to define it in terms of e of s. So we substituted that. This is in terms of r of s and g of s. So you can directly substitute and find out the value.
Okay, so you did.
Alright.
Okay.
So
Yes.
this goes from here to here. Now, your
Okay.
r of s basically can be 3 or 4 inputs.
Gotcha.
What's the middle one saying?
Hmm?
Sorry, right side, the board, the bottom, the RS. You got 1 step.
This is 1 is impulse.
Okay, 2 is step.
This is r of s is 1 over s for step. That is what you have been doing, right?
Mm.
R of s is 1 over s square for ramp function.
Oh, that's RAM. Okay.
Okay, r of s is 1 over s cube
That's
for
parabola.
Is
parabolic.
it ramp or RAM?
Ramp.
Okay.
Like what you jump.
So you have to understand these waveforms, okay? And I'll do that now.
But you'll access for that though, right?
Huh?
You'll access for it, right though?
I will give all those.
Yeah, like you'll say like what's the step or what's the RAM.
Yeah, I'll give you the table. I won't give you the transfer function itself. You have to figure out, or you have to. It's easy to memorize as well. It's really simple.
What chapter is this in the book?
7, I think.
No.
You can take.
Okay, you're good except for equation 4. And then everything to the right of your diagonal line.
Keep them in class.
Hey, Torius. Leave me alone.
You want this?
I needed it, but I'll get it from Torius.
Get it from Torres, yeah.
James,
Okay.
send me the pic.
I'm going to derive those. I will do that again.
Okay.
Okay. I'm going to derive those for your. So let's go by the basic definition of slightly more convenient definition, which is E infinity is, in terms of R of s and G of s, it is limit as s tends to 0, right? S, R of s
Over 1 plus GS.
1 plus G of s. Okay, this is the very basic definition, or a slightly more convenient definition. Okay. For R of s, if R of s is step input, okay, then R of here, what I'm going to mention is you can actually look at it in the function, the context of time. Okay, then R of s is 1 over s. Now E step will simply become limit as s tends to 0, s 1 over s divided by 1 plus GS, right? You with me?
Mhm.
And these cancel off, correct?
Mm-hmm.
Correct.
So this will become
That's the
One
one.
plus
limit s tends to 0, 1 over 1 plus.
Can you break that apart?
Huh?
Can you make it 1 over 1 plus 1 over
No, you
GMS?
cannot break it like that.
Okay, maybe I can brush it with my algebra.
If R of t is ramp input, okay, R of s is equal to 1 over s square. Alright, now E ramp will become limit s tends to 0, s 1 over s square, right, divided by 1 plus g of s, right? Guys, pay attention. Please keep your cell phones away. Here it's going to be 1 over s plus s gs. Do you understand this transition?
Mm-hmm.
No,
So-
wait.
Only one s remains here, right?
Okay, no, I think this.
It gets multiplied by this and this. You got it?
Good to go.
What is this value?
S?
This s.
Just S?
Yeah, s is 0.
Could be 0, yeah.
Okay, so this essentially becomes
1 over 0.
No, 1 over S.
Or
times
is it
GS.
SG of S? That's right at 0. So you wouldn't. So just okay. So you would leave just S by itself and make it 0. You wouldn't say at 0 times G of S too.
it is 0 plus s gs. You just leave out 0.
Okay.
Now similarly, now keep in mind, I have talked about this. This is how step function is. Okay. You have time, step function is like this. It is one step. Okay. How is ramp function?
To
Would
be
be diagonal.
It will be a diagonal, yeah. Not diagonal, but it will have a
incline or slope.
slope.
Or you should,
That's what she said.
So E of next,
Yeah, your problem. Are you gonna do impulse too?
if R of t, we will not do impulse. I can do impulse. That's not a problem. If R of t is parabolic input, then R of s is 1 over s square. Okay. So here E
S cubed.
s cubed, right, of infinity is equal to limit as s tends to 0 s 1 over s cubed divided by 1 plus gs. Again, this will
You have S squared plus S
simply
squared
becomes
GS.
limit as s tends to 0 1 over s square g of s.
Should your graph be like a undamped line?
No, it will be like this. So parabolic input,
I mean, under.
it will be like this.
Oh.
Okay. So think about this. This is constant input. All right. This is essentially testing your systems for various. When do you experience this for an aircraft?
Take off.
Take off, right? When you're taking off, you need to ramp up the input. When do you experience this? Cruising, right? When do you experience this?
That one? That's like emergency maneuvers.
Right, so those are the even for something like a fighter aircraft, that could be the input could really go exponentially high.
Don't we need to see impulse?
Huh?
Don't we need to see impulse?
Impulse.
So
Is impulse. Okay. R of S is what?
1.
1. Then E impulse is limit S tends to 0 S over 1 plus S GS. Right?
Oh. Well,
No, G of
No.
S. G of S. Okay. What is this? This is not relevant. Can you tell me why?
it's not what?
It's not relevant.
Because it'd be 0.
It will be 0.
Mm-hmm.
Okay, so that's the reason we don't discuss this. All right, but the impulse function will look something like this. You have where do you experience this? Aerospace systems.
On
Uh,
would that be like a stall?
Hmm?
No, never mind. Sorry. That's right.
we did some experiment where we were trying to get that as clean as possible, like we want it to be. I'm gonna bring.
No, where do you experience in an aerospace systems?
Where your input increases dramatically and then it drops off.
Example, I know that. I don't need an explanation.
No,
Example.
I'm just making sure that we're on the same page.
Maybe the initial cut on of the system, like cutting it on, activating it.
Huh? Thrusters, impulse maneuvers, all your spacecraft. Get out of the aircraft realm once in a while.
We've been in the aircraft realm before.
But you have to come into the spacecraft realm as well.
And I'm not, okay.
You see, all your maneuvers are impulse maneuvers for a spacecraft. It will be one impulse and it will go. If you're going to do a orbit transfer, you're going to do, what is a Hohmann transfer? In this context. Remind me, what is Hohmann transfer?
It's the simplest way to change orbits with the least number of maneuvers. It's a 2 input.
2 impulse, not 2 input.
Sorry, impulse. What I meant.
It's a
But
2 impulse
impulse
maneuver. Okay. So you're going to experience this 2 impulse maneuver. Okay. What this tells you is a dynamic system can have these different types of inputs. Okay. And we need to analyze their response to this system, to these type of inputs. If you break down your mission profile, so what kind of input are you supplying to your mission profile from takeoff to landing?
What kind of mission profile in this case?
In terms of, it will be a combination of these.
Yeah.
Okay, so if you test the system for these, you'll know how it will respond. You got it? So when you're landing, it will be the opposite. Alright? So here, it will go like this, it will slow down, and you have to test it for how the system is going to respond and what is the steady state error in each case. So I'll quickly do an example and we'll wrap it up for today. Yeah.
Or does that say EPA?
E para,
Okay.
parabolic input.
Okay. Shouldn't the S squared be distributed to the whole as well?
Yeah, so what will happen is, think about this, okay? It'll be S, it'll be S plus S into G of S. It will be S square plus S square GS, right? But what is S?
0.
0. So that S will go off. This S will not go off because there might be a S in the GS which will cancel. You got it? So this S square will be S square plus S square G of S, right? But S will vanish because S is 0. By itself, it will vanish.
Is it supposed to be 1 over S squared? Because it looks like you have 1 over S cubed.
This 1S will cancel, right? Here.
I'm just asking if it's supposed to be squared or cubed. Oh, okay, so you did. So it's 1 over S cubed. It's 1 over S cubed.
Here?
Yes, in the very top RS.
R of S
Oh, it
equals.
looks like.
Yeah, that is cube. Yeah.
Okay, so I thought it was squared.
No, I put it as Julian pointed that out. Okay. So if you take a look at a quick example. I'm going to erase this, okay? So it will be something like
On the test, you're only going to test our knowledge on like one system, right? Like we're not going to get like 2 systems. We're not going to get 2 systems. Of,
what do you mean 2 systems?
you know how we were doing
In the past, you know how sometimes you throw a curveball at us and we don't know how to do it on the test?
yeah.
That's what I'm talking about.
It's exactly what it is.
What do you mean? Curve. I don't throw any curveball.
You know, it's called change up.
It's the fundamentals before the whole switch to it.
Okay, so if I ask you to find SS error for five U of t, 5t U of t, 5t squared U of t. Okay.
The first one's an impulse. The second one is a step.
This is what?
Right. That's an impulse.
That's step.
That's step.
It's not unit step. Unit step is UT, okay?
Okay.
This is just a step input.
Okay.
This is
So that's going to be your
ramp, okay?
Yeah, okay.
And this is
That's your parabol.
parabola.
So, okay.
What you want to do is you don't want to apply this why don't we apply this? You can apply these formulas. So here, what does E step become? So it is this, right? This is the basic definition, okay? S R of S divided by 1 plus G of S. You with me? This is the basic definition. So what is R of S?
For step up. So over S.
If R of T is equal to 5 U of T, R of S is what?
1 over S. Or it'd be 5 over S.
5 over S. Okay. So you're going to get E step here would be limit as S tends to infinity. So S tends to 0, 5 divided by 1 plus
S. Or G of T. Or G of S. Why? So why wouldn't we use the T? So
where are you going to?
So I'm just curious because you got it right there. Like, so you have ramp 5T UT. So
Yeah, this R of S, this is R of T.
Yeah,
You take the Laplace transform and you get
understood.
Laplace transform.
Gotcha.
No, I understand that part, but like, I'm just trying to recall. So you have like 5T.
You take the Laplace transform, you're going to get 5 over S squared.
The T, bro. You told me the T.
Yeah, Tony's actually
I'm
Tony's moving on
confused.
to the next
And
problem.
it's because I'm forgetting Laplace transforms.
Let's finish this problem first, and then let's go to rank.
Okay.
I think it might make more sense.
Okay, so here it is 12
I see you're thinking though.
S plus 2, S plus 3, S plus 4. Alright, so here what is E step? You just have to substitute S equal to 0. So what you're going to get is 12 into 2 divided by 3 into 4. Right? You with me?
Yes.
So this will be
24.
5 over 1 plus
That's 24 over
12 into 2, right?
Yeah.
Divided by 12, right?
Oh, so that's
5
their 0.
thirds.
That's right. Track.
5 over 3. Okay, this is how you solve. So E similarly, E ramp is what? Instead of 1 you will have limit as S tends to 0, 5 divided by S into G of S. That is the parabola. Look at the ramp I gave you here. Okay, it is. Anybody?
Would be 5 over S of. Wait, is this.
This is the ramp one.
Okay.
It's infinity. You can compute it yourself. What is G of S when you substitute S equal to 0?
0.
G of S times S.
It is 2. Or it is, yeah, it is 2, right?
Okay.
Mm-hmm.
So 2 into 0 is what?
0.
Something over 0 is?
Infinity.
Okay, and similarly, E parabola is also equal to infinity. Because it will be again, G of S is what? When you substitute S equal to 0?
Be
2.
2. 2 times 0 is?
0.
0, and 1, something over 0 is?
Infinity. So how does it being if infinity? Never mind. I'll ask that question later. I'll ask it.
Yeah, that's a good question. So what's going to happen is this system, for this system, if you apply a ramp input, the steady state error will be huge. It will never get there. Does that make sense?
Mm-hmm.
So what is steady state error? Steady state error is essentially you have a system like this, right? This is the steady state error. Once it settles, and that's what you did in the experiment. You remember?
Yes.
So, but what is the steady state error this for? This is a steady state error for what input? What kind of input? What kind of input is there?
That's undamped.
Input. That's a step input. Do you see it as a step input?
Yes.
The dotted line. That is the input.
Oh, okay, gotcha.
Okay, so here in your ramp response, your dotted line will be like this.
Okay, I get what you're saying now.
Okay.
Oh, okay.
And the input, the response will be, we'll try to do this, and it'll
That's 'cause
This-
that's
yeah.
the constant, right?
this will potentially become infinity.
Okay, so your input is your dotted line because that's your constant, right?
It's not constant. It is this function.
I mean,
It is an
but
amp
it's
function.
It's going to change to like whatever it is, though.
Yeah.
Okay.
The input, ultimately it will try to follow the dotted line. Depending on what system it is, here it is infinity, right? Here it is, this system, you have this system, right? And here you're going to see that the ramp input, the steady state error is going to become huge and huge and huge. And similarly for parabolic input.
Mm-hmm.
The difference once it settles down. It's trying to reach there, but it will never reach there. Alright? Any questions? Good? Alright.